This lecture will take a look at immunological memory. And basically, immunological memory is what provides us with long-term resistance against the presence, of various foreign antigens. So what you have here is a diagram that shows you time, measured usually in days, along the x-axis. If you look along the y-axis, you have what's called an antibody titer. A titer is basically a measure of the amount of an antibody or an immunoglobulin that may be present within blood. You can see it's measured in arbitrary units, so the units don't really matter. It's all about the level of the titer, and that's what we'll use or utilize for this discussion. In the darker yellow box, you'll see that this details for you the primary response that your body would have in response to its first exposure, at least, to a given antigen. The red line represents the level of IgM. The blue line, represents the level of IgG. During the initial exposure at time 0, it takes your body maybe a day or so to begin to try and figure out what some of the antigens look like. In order to produce the corresponding antibody, your body would go through a process called genetic recombination and basically shuffle your genes and begin to produce B and T cells with, or at least in this case B cells, with different types of B cell receptors located in the surface. Once again, in order to do that, you have to go through genetic recombination. So it could take a day or so before your body eventually figures out a match for some of the antigens present. Once it does, as we mentioned before in the antibody discussion, you'll see that the level of IgM begins to rise, because IgM, being a large molecule with multiple binding sites, is the first immunoglobulin or antibody produced during the body's response to a given antigen. So the level of IgM rises very quickly and usually peaks somewhere around day 6 to day 7. Now, somewhere around day 4, your body continues to figure out more antibodies that will correspond to the antigens introduced, and instead of making exclusive IgM, some of the B cells begin to produce IgG. The IgG is a much smaller molecule, consequently it doesn't take as much to try and produce it. So these cells that produce IgG can usually last longer. So we have IgG being produced as well. And IgG is going to mediate the latter stages of this immune response, because as you can see around day 7, where the IgM tops out, the IgM after that point begins to decline. So it's no longer going to be continuing, or at least continuing to increase, begins to decrease, and is essentially replaced by IgG to mediate the latter stages of that response. And somewhere between day 10 to 14 is usually, if we're talking about maybe, for instance, some type of bacterial infection, it's usually when the person usually begins to feel a little bit better. That's why a lot of times you'll see if you have to take antibiotics or something like that, you have to take them for at least 14 days or 7 to 10 days a lot of times before you actually run your course. So in any case, as you can see here, during the primary response, person would be ill a little bit. They would eventually, their body would begin to recognize the antigen. You would begin to secrete IgM. That would try to mediate the earlier stages of that primary response. And as your body continued into the latter stages of the primary response, you would ultimately see the level of IgG rise. Now, don't forget, due to the concept of memory, you would also have some memory cells that result. Those memory cells begin to exclusively secrete IgG. It's because it takes less energy, the cell can last longer, and basically it's easier for the cell to produce. So the IgG level never fully returns to 0. It actually stays a little elevated, and the IgG is actually the low level of antibody that we see or that's measured that lets us know that this person has gained some immunity. Now, obviously, what if this isn't the only time that person is exposed to that given antigen? So if that person should be exposed again, maybe they'll enter this phase, which is called a secondary response, which is seen on the right-hand side of the diagram. So at day 28, a second exposure occurs. As you can see, it takes a couple of days, but we see the IgM response basically mimic and be the same. However, it's the IgG response that's significantly different. We see the amount of IgG skyrocket even before the IgM is produced. Now, this is valuable because the memory cells that were around have basically quickly recognized their antigen. Once they've done that, you no longer have to wait for that to happen. And because they quickly recognize their antigen, they can begin to produce large amounts of IgG very quickly that will allow you to hopefully neutralize that antigen before it even becomes a problem. Now, in some cases, that's not always the case. You may get a little ill, but in many cases, this happens so quickly and so vigorously that the person who's infected or has been exposed for the second time never even knows that they've encountered that particular pathogen, because essentially the IgG response combined with the original IgM response is enough to mediate any effects. Now, this immunological memory has various ways that it can be named based upon how you acquire it. There are essentially four terms. They are natural versus artificial, active versus passive. Natural acquired immunity means that you acquired it basically via natural means. There was no man-made intervention. Artificially implies that via some mechanism man intervened in order to allow you to get that immunity. Active immunity means your immune system mounted an active response, versus passive immunity, which means your immune system didn't do anything. So we combine the terms and we have the four categories that you see listed here on your screen. First up, naturally acquired active immunity. This is acquired via natural means, and the immune response is basically dependent on that person's immune system. In other words, their immune system is active. The easiest, the clearest example of this is basically when you get sick, you get ill, and then you have immunity long term. Think about the classic case of the chicken pox, where people would get sick with the chicken pox. They would usually recover in 7 to 10 days, and then they would have long-lasting immunity. That's a form of naturally acquired active immunity. Person gets sick, immune system responds, they have immunity after. Naturally acquired passive immunity is all natural, but that person's immune system would not do anything. The most common example of this is the mother passing on immunity to the baby. This could happen via placental transfer in the case of IgG, or via breastfeeding when we look at the IgA that's transferred via breast milk. So naturally acquired passive immunity, all natural because breastfeeding and placental transfer is completely natural. There's no man-made intervention. And passive because the baby's immune system doesn't actually produce any of the immunoglobulins. The mother's immune system would do that. So the baby has done nothing. Artificially acquired active immunity. Artificial means so there's some man-made intervention, but the person's immune system still is going to be active. The most common example of this, vaccinations. Vaccinations are all artificially made, and even with that, the introduction of them via injection, or whether that's IM or whatever the case may be, is still going to be a man-made intervention. But once introduced, that person's immune system responds to that antigen. So that's an active response. So artificially acquired active immunity, easiest example here, vaccinations. And finally, we have artificially acquired passive immunity. Man-made, person's immune system does nothing. Easiest example of this would be a transfusion of antibodies or immunoglobulins. So we have IgG isolates that we transfuse to individuals and things of this nature, and that's going to be your classic example there of artificially acquired passive immunity. So please keep in mind the four different categories and also the examples.